NENOMATICA, where mathematics meets YouTube excellence. The fourth law of power. Let's look at the expression we need to simplify. We have 1,440 to the power of 15 divided by 12 to the power of 22, all over 15 to the power of 30 divided by 6 to the power of 37. Notice that we have division operations in both the numerator and denominator. The first step is to rewrite the divisions as fractions. In the numerator, 1,440 to the power of 15 divided by 12 to the power of 22 becomes 1,440 to the power of 15 over 12 to the power of 22. Similarly, in the denominator, 15 to the power of 30 divided by 6 to the power of 37 becomes 15 to the power of 30 over 6 to the power of 37. Now, when we have a fraction divided by another fraction, we can multiply the first fraction by the reciprocal of the second fraction. So, we multiply the numerator by the reciprocal of the denominator. This gives us 1,440 to the power of 15 over 12 to the power of 22, multiplied by 6 to the power of 37 over 15 to the power of 30. Next, let's combine this into a single fraction. When we multiply fractions, we multiply the numerators together and the denominators together. So we get 1,440 to the power of 15 times 6 to the power of 37 in the numerator, and 12 to the power of 22 times 15 to the power of 30 in the denominator. Now, let's start simplifying this expression. 1,440 can be written as 12 times 120. So 1,440 to the power of 15 becomes open parenthesis 12 times 120 close parenthesis to the power of 15. When we have a product raised to a power, we can distribute the exponent to each factor. So, open parenthesis 12 times 120 close parenthesis to the power of 15 equals 12 to the power of 15 times 120 to the power of 15. Now, we can start simplifying. In the numerator, we have 12 to the power of 15, and in the denominator, we have 12 to the power of 22. We can simplify this by using the rule that a to the power of m over a to the power of n equals a to the power of m minus n. So, 12 to the power of 15 over 12 to the power of 22 equals 12 to the power of 15 minus 22, which is 12 to the power of negative 7. That's equivalent to 1 over 12 to the power of 7. So our expression becomes 120 to the power of 15 times 6 to the power of 37, all over 15 to the power of 30 times 12 to the power of 7. Let's continue simplifying. 120 can be written as 15 times 8. So 120 to the power of 15 becomes open parenthesis 15 times 8 close parenthesis to the power of 15. Again, we distribute the exponent. Open parenthesis 15 times 8 close parenthesis to the power of 15 equals 15 to the power of 15 times 8 to the power of 15. Now, we have 15 to the power of 15 in the numerator and 15 to the power of 30 in the denominator. Using the same rule as before, this simplifies to 15 to the power of 15 minus 30, which is 15 to the power of negative 15. That's equivalent to 1 over 15 to the power of 15. So our expression becomes 8 to the power of 15 times 6 to the power of 37, all over 15 to the power of 15 times 12 to the power of 7. Let's break down some more terms. 8 can be written as 2 times 4, and 12 can be written as 2 times 6. So our expression becomes open parenthesis 2 times 4 close parenthesis to the power of 15 times 6 to the power of 37, all over 15 to the power of 15 times open parenthesis 2 times 6 close parenthesis to the power of 7. Distributing the exponents again, we get 2 to the power of 15 times 4 to the power of 15 times 6 to the power of 37, all over 15 to the power of 15 times 2 to the power of 7 times 6 to the power of 7. Let's simplify the two terms. We have 2 to the power of 15 in the numerator and 2 to the power of 7 in the denominator. This simplifies to 2 to the power of 15 minus 7, which is 2 to the power of 8. Also, 4 to the power of 15 can be rewritten as 2 to the power of 30, since 4 equals 2 squared, and 4 to the power of 15 equals 2 squared to the power of 15, which is 2 to the power of 30. Our expression now becomes 2 to the power of 8 times 2 to the power of 30 times 6 to the power of 37, all over 15 to the power of 15 times 6 to the power of 7. Now, let's combine like terms in the exponents. In the numerator, we have 2 to the power of 8 times 2 to the power of 30, which equals 2 to the power of 8 plus 30, or 2 to the power of 38. For the 6 terms, we have 6 to the power of 37 in the numerator and 6 to the power of 7 in the denominator. This simplifies to 6 to the power of 37 minus 7, which is 6 to the power of 30. So our expression becomes 2 to the power of 38 times 6 to the power of 30, all over 15 to the power of 15. Let's break down 6 and 15. 6 can be written as 2 times 3, and 15 can be written as 3 times 5. So 6 to the power of 30 becomes open parenthesis 2 times 3 close parenthesis to the power of 30. And 15 to the power of 15 becomes open parenthesis 3 times 5 close parenthesis to the power of 15. Distributing the exponents one more time, we get 2 to the power of 38 times 2 to the power of 30 times 3 to the power of 30, all over 3 to the power of 15 times 5 to the power of 15. Let's combine like terms again. In the numerator, we have 2 to the power of 38 times 2 to the power of 30, which equals 2 to the power of 38 plus 30, or 2 to the power of 68. For the 3 terms, we have 3 to the power of 30 in the numerator and 3 to the power of 15 in the denominator. This simplifies to 3 to the power of 30 minus 15, or 3 to the power of 15. So our expression becomes 2 to the power of 68 times 3 to the power of 15, all over 5 to the power of 15. We can write this in a slightly different form. 2 to the power of 68 times 3 to the power of 15 over 5 to the power of 15 is equal to 2 to the power of 68 times open parenthesis 3 over 5 close parenthesis to the power of 15. And this is our final simplified answer. And there we have it. We've successfully simplified this complex expression step by step. Remember, when working with expressions containing exponents, first rewrite divisions as fractions. Apply the rule for dividing fractions. Break down numbers into their factors. Use exponent laws to simplify. And finally, combine like terms. With practice, these problems become much more manageable. We need to simplify the expression x raised to the power 7 times x raised to the power 15 times x raised to the power negative 3 times x raised to the power negative 9, all divided by the quantity x raised to the power 3 divided by x raised to the power negative 9 times x raised to the power negative 2. To simplify this expression, we'll apply the exponent rules. Let's start with step 1. Combine the exponents in the numerator. According to the rule a raised to the power m times a raised to the power n equals a raised to the power m plus n, we can add all exponents in the numerator. Step 2. Let's simplify the expression in the numerator. 7 plus 15 is 22, minus 3 is 19, minus 9 gives us 10. So the numerator simplifies to x raised to the power 10. Now, in the denominator, we need to apply the division rule for exponents. When we divide x raised to the power 3 by x raised to the power negative 9, we subtract the exponents, 3 minus negative 9, which is 3 plus 9 equals 12. So the first term in the denominator becomes x raised to the power 12. Step 3. Now, let's combine the exponents in the denominator. We have x raised to the power 12 times x raised to the power negative 2. Using our rule again, we add the exponents. 12 plus negative 2 equals 10. So the denominator simplifies to x raised to the power 10. Step 4. Finally, we can simplify this expression fully. When we divide a number by itself, we get 1. So x raised to the power 10 divided by x raised to the power 10 equals 1. So our final answer is 1. Now, let's move on to our second example. In this problem, we need to simplify the expression x squared times x raised to the power n plus 2, and that whole quantity raised to the power n divided by x raised to the power of n plus 1 squared. This problem involves exponent rules with variables. Let's start with step 1. Apply the power of a power rule. According to the rule, when we have a power raised to another power, we multiply the exponents. So for the term x raised to the power n plus 2, raised to the power n, we multiply the exponents. N plus 2 times n, which gives us x raised to the power n times n plus 2. Step 2, let's expand the exponent n times n plus 2. This equals n squared plus 2n. So our expression now becomes x squared times x raised to the power n squared plus 2n, divided by x raised to the power n plus 1 squared. Step 3. Now, let's combine the exponents in the numerator. We have x squared times x raised to the power n squared plus 2n. Using our multiplication rule, we add the exponents. 2 plus n squared plus 2n, which gives us x raised to the power n squared plus 2n plus 2. Step 4. Now we can apply the division rule for exponents. When dividing powers with the same base, we subtract the exponents. So our expression becomes x raised to the power of n squared plus 2n plus 2 minus n plus 1 squared. Step 5. Let's expand and simplify the exponent. First, we expand n plus 1 squared, which equals n squared plus 2n plus 1. So our expression is now x raised to the power of n squared plus 2n plus 2 minus n squared plus 2n plus 1. Simplifying this, we get n squared plus 2n plus 2 minus n squared minus 2n minus 1, which equals 2 minus 1, or simply 1. So our expression simplifies to x raised to the power 1. Let's explore how to work with exponent rules to simplify complicated expressions. Before we dive into our examples, let's review the key exponent rules we'll need for these types of problems. The first rule is that when multiplying expressions with the same base, we add the exponents. When dividing expressions with the same base, we subtract the exponents. When raising a power to another power, we multiply the exponents. And when we have a negative exponent, we can rewrite it as 1 over the base raised to the positive exponent. Now, let's work through our first example. We need to simplify this expression. Let's start by expanding the exponents in the expression. First, let's focus on this term, a raised to the power of m plus n squared. This equals a raised to the power of m plus n quantity squared. Next, let's look at the term a to the power n raised to the power n plus 2. Using the rule that states that when we have a power raised to another power, we multiply the exponents. This becomes a raised to the power of n times n plus 2, which is a to the power of n squared plus 2n. Now, let's apply the division rules in both the numerator and denominator. In the first fraction, we have a to the power of m plus n quantity squared divided by a to the power of n squared plus 2n. Using the division rule of exponents, we subtract the exponents. So, this becomes a to the power of m plus n quantity squared minus n squared plus 2n. Similarly, in the second fraction, we have a to the power of n plus 1 divided by a to the power of 1, which gives us a to the power of n. Next, we'll simplify each fraction individually. Let's simplify the first fraction further. We can rewrite it as a to the power of m plus n quantity squared minus n squared plus 2n minus the quantity 1 minus n. For the second fraction, we have a to the power of n divided by a to the power of 2n, which becomes a to the power of n minus 2n, which equals a to the power of negative n. Now, let's expand the expressions in the exponents. First, we expand m plus n squared, which equals m squared plus 2 million plus n squared. Then we expand n times n plus 2, which equals n squared plus 2n. So our first exponent becomes m squared plus 2 million plus n squared minus n squared minus 2 n minus 1 plus n. For the second exponent, n minus 2n simplifies to negative n. Now, let's combine like terms in the first exponent. The n squared terms cancel out. Combining the negative 2n and positive n terms gives us negative n. So, the first exponent simplifies to m squared plus 2 million minus n minus 1. Now, we've got a to the power of m squared plus 2 million minus n minus 1, multiplied by a to the negative n. Using the multiplication rule for exponents, we add these powers, giving us a to the power of m squared plus 2 million minus n minus 1 plus negative n, which simplifies to a to the power of m squared plus 2 million minus 2 n minus 1. So, our final answer for this first example is a raised to the power of m squared plus 2 million minus 2 n minus 1. Now, let's move on to our second example. We need to simplify this expression. Let's start by applying the power to a power rule to the terms in the numerator. For the first term, we have x to the negative 2, all raised to the power of 3. Using our exponent rule, we multiply these exponents, giving us x to the negative 6. Similarly, for the second term, we get x to the negative 4. Now, let's apply the division rule in the numerator and the multiplication rule in the denominator. In the numerator, we have x to the negative 6 divided by x to the negative 4. Using the division rule, we subtract the exponents, giving us x to the -6 minus -4, which is x to the -2. In the denominator, we have x to the -7 multiplied by x to the 5th power. Using the multiplication rule, we add the exponents, giving us x to the -7 plus 5, which is x to the -2. So, we have x to the -2 divided by x to the -2, which equals 1. Let's take a look at the expression we need to simplify. We have. Before we start simplifying, let's review the key rules of exponents that we'll be using. First, when multiplying terms with the same base, we add the exponents. Second, when dividing terms with the same base, we subtract the exponents. And third, when raising a power to another power, we multiply the exponents. Now, let's apply these rules to our expression. Let's start by combining the exponents in the numerator and denominator using our first two rules. In the first numerator, we have a to the m times a to the n divided by a to the m minus n. When we combine the first two terms, we get a to the m plus n. Then dividing by a to the m minus n gives us a to the m plus n minus quantity m minus n, which simplifies to a to the 2n. In the first denominator, we have c to the n times c to the m times c to the n minus m. Combining these, we get c to the n plus n minus m, which simplifies to c to the 2n. In the second numerator, we have b to the n times b to the m times b to the n minus m. This gives us b to the n plus n minus m, which also simplifies to b to the 2n. Finally, in the second denominator, we have b to the m plus n divided by b to the m minus n. This gives us b to the m plus n minus quantity m minus n, which simplifies to b to the 2n. Now, let's substitute all our simplified expressions back into the original equation. We get the quantity a to the 2n over c to the 2n times b to the 2n over b to the 2n, all raised to the power of m. Let's simplify further. In the second fraction, we have b to the 2n divided by b to the 2n. Since these are the same, this fraction equals 1. So our expression becomes the quantity a to the 2n over c to the 2n times 1, all raised to the power of m, which is simply the quantity a to the 2n over c to the 2n raised to the power of m. Now, we need to apply the power of m to our expression. Remember our third rule. When raising a power to another power, we multiply the exponents. So when we raise a to the 2n over c to the 2n to the power of m, we get a to the 2n times m over c to the 2n times m. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.